In this video, I will show you how to solve word problems using matrices. Now, once we set up the matrix equations, we will be using the TI-84 to solve those. An instructor wants to write a quiz with 9 questions where each question is worth 3, 4, or 5 points based on difficulty. He wants the number of 4-point questions to be one more than the number of 3-point questions, and he wants the quiz to be worth a total of 35 points. How many 3, 4, and 5-point questions could there be? So that last sentence tells us what the variables need to be. So focus your eyes on that. So this is a little bit awkward to write, but the different types of questions are 3-point questions, 4-point questions, 5-point questions. So we just have to kind of write it like this. We'll let X be the number of 3-point questions. I'll just say the number of 3-point. We'll let Y be the number of 4-point. And we will let Z be the number of 5-point. Okay, if they were nice to us, they're going to give us the total amount. I love a quantity equation. Did they give us the quantity this time around? Yes. Were they nice? I heard wait, yes. Let's see. So quantity. So if they gave me the total amount, then that will mean X plus Y plus Z. What's the total amount of questions? 35.
Oh wait, no, it's not questions, it's points.
Writing a quiz with 9 questions. That's the total amount. What was wrong with the 35? That's points. So that's going to be a second equation. All right? So we'll have an equation based on points. So they said, well, obviously there are 3-point, 4-point, and 5-point questions. So can anyone tell me what the equation would be? Go ahead. Oh, that's coming next. Right now, I just want an equation that represents points. So for example, what's the total number of points that we want? 35, right? So the total number of points is going to be 35. So now I need some expressions over here that should add up to 35. Okay, 3x plus 4y plus 5z, right? 3 points per that type of question, 4 points per that type of question, 5 points per that type of question. Should add up to 35. Does that make sense? Okay. Now, back to Hank for the random. So they throw in one random question, random equation. Okay, so Hank, I hear you referring to this part right here. He wants the number of 4-point questions to be one more than the number of 3-point questions. Right there. Let me write this off to the side in case we need to change it to standard form or something. Okay, tell me that equation again. Okay, he said y equals x plus 1. The number of 4-point questions should be one more than the number of 3-point questions. So that makes total sense. Can everybody see how Hank got this equation right here? Does that make sense to everybody? Okay. But in standard form, can you put it in standard form for me, Hank? Negative x plus y is equal to 1. All right, so there he's just subtracting x from both sides. Okay, have I lost anybody so far? No. All right, so we're going to use our calculator to solve this. So first we need to write this as a matrix equation. So looking at the coefficients, I have 1, 1, 1 from the XYZ. I have 3, 4, 5 from the second equation. What will be the third row? Negative 1, 1, 0. All right, so that is my first matrix. Drew.
Is that first one, is that supposed to be negative?
That first one is supposed to be negative because we have negative x.
Oh, wait, never mind.
Okay. And then we have the variable matrix, which is just x, y, z. And that will equal the answer matrix, which is 9, 35, 1. You must label these matrices. So I'm going to call the first matrix A, and I will call the variable matrix X, and I will call the last matrix B. Because we're doing this on the calculator, there's not much work to show, but what little there is comes from these labels, because you must write the matrix equation AX equals B. So if I want to get X by itself, so what am I about to write? What's the next step? X equals A inverse times B. All right, that statement is mandatory. You can't skip that. Make sure your matrices are labeled, and make sure you write down these two little matrix equations. Okay, because the rest is all on the calculator. So to find the answer, we will type in matrix A and matrix B into the calculator. So get ready to read me matrix A in a moment. So I'm going to go to the matrix area. I'm going to edit matrix A. Make sure it's a 3 by 3 matrix. What's the first row?
1,
1, 1, 1.
3, 4, 5.
3, 4, 5.
Negative 1,
1,
1, 0.
0. Quit your way out of a matrix. Then I'm going to go back to the matrix area. This time I will go to edit and matrix B. Make sure it's a 3 by 1. All right, what's this matrix?
9, 35, 1.
9, 35, 1. All right, quit your way out. Now we need A inverse B on our screen, just like we wrote down in OneNote. So we will type matrix A by going to the matrix area, and we will simply hit enter because we're already at A. So there's A. I'm going to hit X to the negative 1 power button. That makes it A inverse. I go back to the matrix area. I'll go down to B. So there's A inverse B. So if you hit enter now, these are the answers. 3, 4, 2. Okay, so that tells me that X is equal to the matrix 3, 4, 2. Okay, now you can't stop there. Because this was a word problem, you have to go on and put your final answer in words. So for full credit, your final answer should look like this. You should make 3 questions worth 3 points, 4 questions worth 4 points, and 2 questions worth 5 points. All right, let's see. Problem number 5. Restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations. That sounds like nonsense. I think we're just going to ignore that part of the sentence. Extra information that we didn't need to know. 20 fewer roses than daisies. See, that's nice and concrete. That's what we need. The total order came to $589.50. How many of each type of flower was ordered? the last sentence tells us what the variables need to be. So boom, I'm going to highlight that. All right, that tells us, wait, how many types of flowers are there? 3. Okay, so we're going to let x equal the number of, what do we got? Carnations. We will let y equal the number of roses, right? Okay. And z will be the number of daisies. Okay, were they kind enough to give us a quantity, a total quantity this time? Okay, great. I love it when they give me the quantity. Easy peasy. So we're going to have a quantity equation. That's the most common equation that there is. So what will the quantity equation be? Anybody? X plus y plus z is equal to 200. All right? What other type of equation am I going to have? Money, all right? They give me money per each type. So we're going to have a money equation. All right? What is the money equation going to be?
150x plus $5.75 y plus 260 c equal to 589 cents.
Awesome. So this will be the money. This will be carnation money. And this will be Rose's money. And this will be Daisy's money. For a total of the total money. All right? Makes sense, doesn't it?
Yes.
So probably now is the random equation. They throw a random one in there. Because we need 3. Okay, the random one is the one that sometimes causes trouble. 20 fewer roses than daisies. All right, so I'm talking about roses versus daisies. All right, so what does this equation need to be in terms of roses and daisies?
20 less, 20 fewer rows.
Okay, so am I going to do minus 20 on the, or minus 20 on the daisies?
20 on the daisies.
So
Or you
roses
plus 20.
equals daisies minus 20. Does everybody agree on that? Okay. The let's see. It says there are 20 fewer roses. So I think we can all agree that there are fewer roses, right? And there are more daisies. So it makes sense that we need to subtract from the quantity that has more so that it will equal the quantity that has fewer. All right, does anybody need me to pause the video so we can delve into this deeper?
I was just gonna ask if
Yeah, it would be equally valid to add 20 to the roses and equal that to the daisies. Okay, so let's see, the roses were y, so this means y is equal to z minus 20. Okay, so this would be y minus z equals negative 20. So y minus z, all right, this is in my way now. Equals negative 20. So now we can make our matrix equation. 1, 1, 1. 1.5, 5.75, 2.6. 0, 1, negative 1. Variable matrix x, y, z. And that equals answer matrix 200, 589.5, and negative 20. So this is matrix A. I'm going to call this matrix X. This is matrix B. The following matrix equation is not optional. You must write this down. AX equals B. What's the next thing I'm about to write right now?
X equals the inverse.
X equals A times B.
Correct. Do not skip that. For full credit, you must write that. Now I'm going to go to the calculator. So get ready to read me these numbers, please. Okay. So second matrix, switch to the edit menu. Make sure it's 3 by 3. Okay, the first row is 1, 1, 1. I remember that. Okay, read me the second row, please.
1.5, 5.75, 2.6.
Okay, in the last row.
0, 1, negative 1.
Okay, quit out of a matrix. Go back to the matrix area. This time edit matrix B. Make sure it's a 3 by 1. All right, what was it again?
200, 589.5, negative 20.
Okay, quit out of this matrix as well. So remembering that we want A inverse B, we will go back to the matrix area, simply hit enter for A, hit x to the negative 1 power button, now it's inverse. Back to the matrix area, go to B. So now we have A inverse B. So these are the answers, 80, 50, and 70. Okay, so of course that means that x equals 80, y equals 50, and z equals 70. But for full credit, you cannot leave it like this. If it's a word problem, you have to answer in words. So again, for full credit, your final answer has to be like this. The restaurant ordered 80 carnations, 50 roses, and 70 daisies. If it's a word problem, your final answer should be a sentence.